Okay, so we are in section 2.7 where we're going to use absolute value functions in transformations. This section has similar concepts that we've learned in the past, but um, methods that we're going to use today are very new to the curriculum, so it's best to you know take these things slow, and if you need to watch the videos more than once, I highly recommend that. So starting off, we're going to uh, show you how to graph what is called the apparent function for absolute value functions. Uh, we've been working with absolute value with one variable in mind. Today we're going to have two variables in mind where it's x, which it has been, and also either f of x or y. So when if you did any reading here, it says the absolute value graph is like a V-shaped and is symmetrical with the y-axis, especially with the apparent um, absolute value function. And here's why. So like imagine if I have a graph here, and what I'm going to do is I want to plot some points. So I want to make up -3, -2, -1, 0, 1, 2, and 3. So what these are is these values of x. I'm going to substitute them into the um, our equation y equals the absolute value of x, and then solve for y. So if x is -3, that means I need to find what the absolute value of -3 is. The absolute value of -3 is 3. Absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is just 0. Absolute value of 1 is 1. Absolute value of 2 is 2. And absolute value of 3 is 3. So when I plot these points, so I'm going to go -3, comma 3, -2, comma 2, -1, comma 1, 0, comma 0, 1, comma 1, 2, comma 2, and 3, comma 3. This is where that V shape that they were talking about here, and then I just connect the dots and go from there. So this is what is called the parent absolute value function. The apparent absolute value function has a vertex, and that vertex is whatever the highest or lowest point on the absolute value graph. In this case, it's its lowest point, and that's why it's at 0, comma 0. There are also some things that we can take from the parent absolute value function in a form of transformations. Transformations are the change in the graph's size, shape, position, or orientation. Translations shift the graph either vertically or horizontally and does not change the size. So transformations are where A fall into place in the general equation y equals A times the absolute value of x minus h, which is inside the absolute value um, symbol. And then once we get out of there, it's plus k. So going back to here, if I have a value for A where its absolute value is greater than 1, so whether it be negative or positive, as long as it's greater than 1, it's going to have what is called a vertical stretch. If my value of A is in between 0 and 1, which means is that it's a fraction that is less than 1, but the absolute value is in between 0 and 1, you're going to have what is called a vertical shrink. If my A is negative, my graph will be reflected over the x-axis, and we can prove that by doing our little t-chart that we did for our apparent um, absolute value function. H shows us our horizontal shift change, and K is our vertical shift change. So here's one thing to keep in mind is since it's got a negative value inside of our general formula, so basically what's a good key of thought is always go to the opposite side. So if it says x plus 3, that means you're going to move to the left 3 units. If it says x minus 3, you're going to go to the right. Sounds confusing, but it's just because of the equation and how it's represented. K is the vertical shift, and you just go with whatever sign it is. If it's a plus 5, you're going to move up 5. If it's a minus 5, you're going to go down 5. And here is some examples of translations where it involves H and K. So if I look here, this black graph is the apparent function where it's y equals absolute value of x. So from here, I notice that it's moved to the right 1, 2, 3, 4, 5, 6, 7. So it moved 7 spaces to the right, and then it moved 1, 2, 3, 4 units up. So the coordinate that the vertex is here is at 7 comma 4. And if I were to write excuse me, an equation for this new one, it would be y equals the absolute value of x minus 7, because it moved to the right 7, close my absolute value, plus 4. So that would be the equation for that particular one, because there was no change in the vertical stretch or shrink, but we did shift it to the right 7 and up 4. To my right here, this blue graph is a representation of a vertical stretch, which means that my black one here again is my y equals absolute value of x, and my blue one, whatever that may be, is a value of a that is greater than 1. If I look down here, this green graph, that is a vertical representation of a vertical shrink, where if I have my a is in between 0 and 1, and my last graph here shows the reflection off the x-axis. So this one here is y equals absolute value of x, or this one here is the y equals a negative absolute value of x. Okay? So if I'm going to solve these, solve this graph, first thing I want to do is I want to identify whether this is going to be a vertical stretch or a vertical shrink. I can tell because my a is 1/3. My a is in between 0 and 1. The absolute value of a is in between 0 and 1, and it's 1/3, so that means that this is going to have a vertical shrink with comparison to our apparent absolute value function. So here I have my h equals 0 and my k equals 0, so that means in this particular graph there is no horizontal shifting and there is no vertical shifting. So that means that my vertex is going to be at 0.00. So with it being at 0.00, I can use the same values that help me solve for the apparent absolute value function. So I can still use -3, -2, -1, 0, 1, 2, and 3. From here, I'm taking -3. The absolute value of -3 is 3, and 3 times 1/3 is 1. Absolute value of -2 is 2. 2 times 1/3 is 2/3. Negative 1, absolute value of negative 1 is 1. 1 times 1/3 is just 1/3. 0 times 0 is always 0. Or 0 times 1/3 is 0, I'm sorry. 1/3 times 1 is 1/3. 2 times 1/3 is 2/3. And 3 times 1/3 is 1. So I'm going to plot these points. So I'm going to go negative 3, 1, 2, 3, and 1. Now I got negative 2 and 2/3. That's right about there. And negative 1 and 1/3, which is right about there. And again, 1 and 1/3, 2 and 2/3, and then 3 and 1. So my graph kind of looks like this. So I know that it's a vertical stretch because it's a little bit fatter than my apparent function, and it has the vertex at 0, 0. So that's how we do that graph. For B, here, I noticed that again, 5/2 is above 1 in an absolute value of 1. So that means I'm just without even graphing, it's going to have a vertical stretch. And again, just like in A, my H is 0 and my K is 0. So there's no horizontal or vertical shift. So that means that my vertex, again, is going to be at 0, 0. The only difference is that our A is negative. So with our A being negative, I already know that it's going to be reflected over the x-axis, and it's going to be like pointing downward. I'm gonna erase this, but it's like going to be pointing this way instead of pointing that way like it was in graphs prior. So let me just erase this. I was just showing it to you to give you a little better idea. Okay. So because my vertex is at 0, 0, I can use the same values that I used before to help me plot the graph and then connect the dots. So if I have negative 3, absolute value of negative 3 is 3, and then 3 times negative 5/2, that ends up being like a negative 7.5. If I have negative 2, absolute value of negative 2 is 2. Multiply that by negative 5/2, that's negative 5. Negative 1, absolute value of negative 1 is 1. 1 times negative 5/2, that's what, negative 2.5. 0, 0 times negative 5/2 is 0. 1 times negative 5/2 is still negative 2.5. 2 times negative 5/2 is negative 5. And then 3 times negative 5/2 is negative 7.5. So if I plot these points, so I got negative 3, 1, 2, 3, and then I got 7.5. 1, 2, 3, 4, 5, 6, 7.5. 2, negative 5, 1, 2, 3, 4, 5. And then I got 1 and 2.5, so I got 1, 2.5. And then the same value, so 1 and 2.5. I got 2 and negative 5. And then I got 3 and negative 7.5. So this is where I plot my points here. Okay. Looking at example C, this is where A is 1, so there's no distinct vertical stretch or shift that is different from our parent function. What is different is that our vertex is going to change. Since A is 1, that means there's going to be no stretchers. So, but now that means we're going to have an H and we're going to have a K. And so using the general equation where y equals a times the absolute value of x minus h, so that means that if it's x minus h in the general form and it's x plus 4, that means that my h ends up equaling negative 4. here my k will end up just being equally -6. So what this means is that if h being -4, that means that my vertex is going to be shifted 4 units to the left and 6 units down. So I can go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So right here is where I am plotting my vertex, which is at -4, comma, -6. That's where the new vertex is, where it was usually at 0, comma 0. So from here, this is where my plotting of x and y points changes. And what I have to do is look at my x-coordinate. My x-coordinate is -4. So what I want that to be my middle. So I want to do 3 more units that are less than that, and then 3 more units that are greater than that. That's going to help me graph it. So I want -5, -6, and -7. And I also want -3, -2, and -1. So if I have x being -7 plus 4, that gives me -3. 3 minus 6 gives me a -3. -6 is x, so that means -6 plus 4 is -2. 2 minus 6 gives me a -2. -5 plus 4 is -1. That gives me 1, so 1 minus 6 gives me a -5. 4, 4 minus, or 4 plus 4 is 0, minus 6, that's -6. That holds true with my plotted point I already have here. -3 plus 4, which would give me 1, so that gives me a -5. And then -2 plus 4 is 2, or -2 plus 4 is 2, and then minus gives me -4. -1 plus 4 is 3. Absolute value of 3 is 3, minus 6 is -3. So I can plot these points. So I got -7, so I got 1, 2, 3, 4, 5, 6, 7, and down 3, 1, 2, 3. So now I can go 6. This should be -4. 6 and -4, -6 and -5, and -4 and -6, which I already have, -3 and -5, -2 and -4, -1, -3, and I can plot these points. And that is my new absolute value function when it's shifted to the left 4 and down 3. Here for D, I'm going to have, not only am I going to have either a stretch or a shrink, but I'm also going to have a shift in my vertex, which means is I'm getting a H and a K here. So here I got X plus 2, which means it's the opposite, so my H is -2. My K is at a +7. So looking at usually my apparent function is at 0, 0, which means I'm going to shift my vertex 2 units to the left and 7 units up. 1, 2, 3, 4, 5, 6, 7. So this is where my new vertex is going to be located. Now that I pinpoint that, now I can pay attention to my A, which is going to tell us whether it's going to have a vertical stretch or a vertical shrink. Because it is in my absolute value of this number, which is -1/4, is in between 0 and 1, that's going to tell us that's going to be a vertical shrink. And also because it has a negative value, that means that my V is going to be pointed downward, so it's going to be looking like this. Again, I'll erase this real quick. It's going to come in this kind of motion rather than an upward motion like it has before. So let me erase that real quick. Okay. So again, when I'm making the table, I can't use the standard -3, -2, -1, 0, 1, 2, and 3. I have to use my middle, which would be -2. So that means I can use 3 units smaller, so I can go -3, -4, -5, and I can go 3 units bigger, so I can go -1, 0, and 1. Okay? So if my x is -5, so -5 plus 2 will give me a -3. Absolute value of -3 is 3. Now if I multiply that by a -1/4, that gives me a -3/4. I add that to 7, that gives me positive 6.25, or 6 1/4. Now if I go to -4, -4 plus 2 is -2. Absolute value of -2 is 2. 2 times a -1/4 gives me -1/2. Add that to 7 gives me a positive 6 1/2. Go to 3. -3 plus 2 gives me -1. Absolute value of -1 is 1. 1 times -0.25 is just -1/4. And if I add 7 to that, that's just going to give me 6.75. If x is -2, -2 plus 2 is 0. Absolute value of 0 is 0. 0 times -1/4 is 0. 0 plus 7 is just 7, which makes sense because my point on my vertex is -7 comma, or -2 comma 7, I'm sorry. So now I'm going to go -1 plus 2 gives me 1. Absolute value of 1 is 1. 1 times a -1/4 is a -1/4. -1/4 plus 7 goes back to 6.75. And if my x is 0, that gives me an absolute value of 2. Absolute value of 2 is positive 2. 2 times a -1/4 is -1/2. -1/2 plus 7 gives me 6.5. And for 1 plus 2 is 3. Absolute value of 3 is 3. 3 times -1/4 gives me a -3/4. -3/4 plus 7 gives me 6.25. So now I can plot these points. So I can say -5. So I can go 1, 2, 3, 4, 5. I can go up 6. 1, 2, 3, 6. So I would say about 6.2. Oh no, let me try that again. 1, 2, 3, 4, 5, 6. So I would say it's right about there. And then -4 and 6 1/2, which would be right about there. -3, 6.75, which is right about there. 2 and 7 I already plotted. -1 and 6.75. 0 and 6 1/2. And then 1 and 6.25. So I would make my graph look something kind of like this. Okay? Has a vertical stretch. Makes sense with the -1/4. It's a negative value, so it's pointing downward. And I have the appropriate shift with the equation that it's given me. Last thing that we're going to talk about is transformations of any type of general graph. Not necessarily absolute value, but it still kind of has the same concepts. Here is you're going to be given a graph y equals f of x. So if you come down here for our example, this is what our coordinate, our graph is, which is y equals f of x. Then you're going to be given an equation y equals a times f of x minus h plus k. So initially what you're going to do is you're going to look at that stretch or shrink, which is represented by A. What you're going to do with this A is you're going to multiply the Y value by A. So let's do that first. Let's look down at this equation here. So our equation here is going to be y equals negative 2 f of x minus 5 plus 1. So here our A equals negative 2. So what I want to do is I just want to plot the points that I have originally. So now I have 0, comma 0. This I have 1, 2, 3, and then 1, 2. So this is 3, comma 2. And then this point here is 1, 2, 3, 1, 2, 3, 4, 5. So this is 3, comma, this is actually negative 2, and this is 3, comma, negative 5. I'm sorry. Okay, so the first step is all I want to do is plot new points dealing with my new value of A. So all I'm paying attention to is the Y value because that's what my directions tell me. So I'm going to plot a new point with that new y. So what I'm going to do is I'm going to multiply 0 times, or negative 2 times 0, negative 2 times negative 2, and negative 2 times negative 5. So let's see if I can get a different color. What if I just have green? So negative 2 times 0 is going to be 0. So here I have 3, comma, negative 2, but I'm going to multiply that by a negative 2, so that gives me 3, comma, 4. So I got 1, 2, 3, 4. So that's where this new point's going to be located. And then I have 3, comma, negative 5. But negative 5 times the negative 2 gives me 10. So I'm going to move it up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I were to connect these dots here, this would be my new graph if all I had to do was change the stretch by negative 2. But I can't. So now what I have to do is I'm giving other parameters. So here I can determine if it's reflexive of the original graph, if it's a negative number, which it is, which I already did that. Now I'm going to pay attention to number 3, where it talks about the shifting of the graph. And the shift of the graph deals with the horizontal h units and the vertical k units. So this is where h is and that's where k is. So if I go back to my original equation, so I'm going to change the color here. I'm going to plot new values by saying that I'm going to say that h equals 5 and k equals 1. So that means that each point that is now in green, I'm going to shift it 5 units to the right and 1 unit up to make my new graph. So now I'm going to go to this one. So I'm going to go 1, 2, 3, 4, 5, up 1. So that's my new value, which happens to be 5, comma 1. Okay. Now I'm going to go to this one here and move it 1, 2, 3, 4, 5, up 1. And then this is what? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So that's what, 8, comma 5. Now here again, taking this one, I'm going to move it 5 units to the right. 1, 2, 3, 4, 5, and up 1. So this becomes 8, comma 11 is my new point. Now from there, I can make my graph. So what started out as something that looks something like this now ends up looking something kind of like this. Okay? And that is being able to use absolute value functions and transformations. Hope this helps. Until next time.